Lights.
Camera.
Create.
A Teenager's Guide to the Galaxy.
Hello everyone, I'm Simone.
I'm Nana.
I'm Aziza.
I'm Jose.
And I'm Daniela. Welcome to our planetarium show.
Many wonderful students, including us, created this fabulous show.
It was fun. And challenging. The universe is pretty big, you know.
We've got a lot of places to visit, so let's get going.
Our very first stop is our own planet Earth.
Check out our world now. Look at all the amazing things we've done. All our technology and great advances. But how did we get here? Let's go back. Almost 14 billion years ago, before we, the Earth, even existed. Back to the beginning of time.
Billion years after the Big Bang, we were born as part of the solar system. We started as a gigantic swirling cloud of gas and dust called the solar nebula. The remnants that did not fall into the sun congealed to form miniature planets called planetoids. These, in turn, came together to make the planets. We,
How are you?
the Earth, began as a red, hot, fierce ball of molten rock. As we cooled, we were being bombarded by space rocks. The impact of one of these rocks, an object the size of planet Mars, broke away chunks of the Earth, leaving a ring of debris circling our planet. This debris collected to form our moon. Millions of years passed, and we kept cooling down. We cooled enough to form land masses called continents, and with the right material and pressure, water came to be. Due to the pressure and gravity, our land masses continuously move. This is called continental drift, or plate tectonics.
We saw life branch out like crazy with the Cambrian explosion around 500 million years ago. Plant species grew and diversified all over the place very rapidly. The growth and diversity of animal species exploded and evolved as well.
It took a while, millions of years, but as new animal species continued to appear, modern humans finally emerged about 200,000 years ago. Not long ago, humans started to build cities and made great technological advances. However, the technology that has helped us has also brought consequences in the form of global warming and pollution. These consequences have had devastating effects.
Wars can also disrupt the delicate balance on our planet. We humans must work together to prevent the possibility of a nuclear war.
Come here. Take that. I'll show you.
Large comets and asteroids are always lurking about in space. We may have to stop these large objects from destroying life on Earth, or the Earth itself.
In the very distant future, we humans have to be ready to leave our planet Earth and find a new home. Why? Because in 5 billion years, the sun will slowly expand and engulf the Earth as a natural part of the star's life cycle. The future can sometimes be frightening, and no one can predict what will happen. But one thing is certain, it's all up to us to preserve our planet for future generations.
Alright, I'm dizzy. Whoa!
We really need to take care of the Earth and preserve its resources.
Especially all of its water. Let's find out why.
Hydrogen came from the Big Bang. Oxygen came from the heart of a big star. Together, they make the water, H2O, that we need to survive.
Water is essential for life.
Water can be used in different ways.
Water quenches the thirst. Water keeps you healthy.
Water shouldn't be taken for granted.
Remember, we need to conserve water. We need it.
Water makes you strong.
The human body is about 60% water. Our hearts and brains are 73% water. Our blood has the most water at 92%. And even our bones are 31% water.
In ancient days, everything revolved around water. You can see the word agua in Aquarius, the water bearer. There's Pisces, the 2 fish. And here's Cetus, the sea monster. Oh, and Delphinus, the dolphin.
Roman aqueducts, or waterways, are among the greatest achievements in the world. They brought running water to the cities for indoor plumbing and sewage systems. Aqueducts use gravity to move water by flowing downward. The water comes from wells, lakes, and rivers.
Today, we still use water all the time.
We water plants.
We use falling water for power.
We take showers.
We use it for cooking and washing dishes.
Before water goes back into our lakes and rivers, we clean it at wastewater treatment plants.
So we can use water for recreation and having fun.
Water works wonders. It's a polar molecule, meaning it has positive and negative charges. When a salt molecule comes along, The positive hydrogen pulls on negative chloride, and the negative oxygen pulls on positive sodium. Remember, opposites attract. The water breaks up the salt. That's why water is the universal solvent.
Can water be found beyond the Earth?
In our solar system, two of the best candidates for water are Mars and Europa.
Early Mars had a thicker atmosphere and a warmer climate that supported water on its surface. Today, there still may be water beneath the surface of Mars. Europa has an icy shell that is many miles thick and floats on a giant saltwater ocean. There may also be water on many of the exoplanets beyond our solar system.
In the future, water on Earth may be even more limited. So we need to take care of the water we have now. We need to conserve our most precious resource. Because we need water to survive.
So what I'm hearing is, whenever I drink a glass of water, I'm basically drinking star juice.
Speaking of stars, let's look at our star, the sun. Star juice, really?
Yeah.
From morning to night, we never escape it.
It fuels us and everything around us.
It warms us as we enjoy nature.
It can even be used to tell time.
But where does all this light and energy come from?
93 million miles from Earth, we find the sun.
Wait a minute, Pauline. Why is the sun so hot if it's so far away?
Well, Gus, the sun is 93 million miles away. But you don't realize just how huge and hot the sun is.
Well, show me then.
Okay, first I'll show you how big the sun is. If the sun was shrunk down to a ball 10 feet wide, the Earth would only be about 1 inch across, and Mercury and Venus would be even smaller. Of course, if the Earth was right next to the sun, we'd burn up. But we are a safe distance away, about 3 blocks on this scale. See this bowling ball? It bends the fabric to keep the smaller ball going around it. The sun works the same way. It bends space, creating a gravity well which pulls our planet inward, but the Earth's great speed keeps us a safe distance away. If the Earth ever stopped, we would fall straight into the sun. Or if the sun and its gravity suddenly disappeared, we would go shooting off into space.
Uh-oh, bye-bye, Earth. I get that the sun is big, like really big, but what's inside it, and what makes it so hot?
The sun is a lot like an onion because it has many different layers. There's the corona, the photosphere, the convection and radiative zones, and in the middle is the core. The core is where the nuclear fusion takes place. Countless hydrogen atoms fuse into helium and produce massive amounts of energy. This energy makes the sun so hot that it's pretty much all plasma.
What's plasma?
Plasma is the fourth state of matter. It's when tiny electrons can't stay attached to their atomic nucleus. The sun produces so much heat there is a constant solar wind blowing outward. When solar storms shoot out billions of charged particles, they can collide with Earth's atmosphere and create the colors of the aurora borealis, or northern lights. Aren't they beautiful?
It's amazing all the things I didn't know about the sun. After all, we all needed to survive.
And, by scientists' calculations, it will keep on shining 5 billion years into the future.
Let it shine.
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 Let it shine, baby.
Sometimes we forget that the sun is similar to the billions of other stars in the galaxy.
Next, we will travel back in time to see the birth of stars and everything else in the universe.
Imagine the entire history of our universe, all 13.8 billion years compressed into one calendar year. This is the cosmic calendar. Time is so compressed here that 1 month equals 1 billion years. 1 day is almost 40 million years. 1 second is 400 years. This means that the telephone was invented less than a second ago. The smartphone came along like a millisecond ago.
It's December 31st, just before midnight. So, how did we get here?
It started with the Big Bang, a burst of everything.
The Big Bang was the hottest thing imaginable. It was the start of all space and time. Since then, the universe has been getting bigger and colder every day. After 380,000 years, the universe expanded enough to allow its light to shine uninterrupted. The Dark Ages were over.
Soon, after the Dark Ages, the first stars and galaxies quickly emerged.
All the hydrogen and helium there is was created in the Big Bang. These hot gases quickly clumped together to make the first stars, about 200 million years after the universe began. With today's amazing telescopes, we can see one of the first galaxies ever to form. This ancient galaxy formed soon after the first stars, about 400 million years after the Big Bang.
It took almost 9 months for the Sun and Earth to be born. A supernova is the explosion of a giant star. Many supernovae flooded space with clouds of gas and dust called nebulae. This gas and dust mixed with other space clouds to make new stars and planets. In one case, a nebula collapsed to create the Sun, the Earth, and all the other planets, moons, asteroids, and comets in our solar system.
But what about the future? The next cosmic calendar.
In the future, I see cars driving themselves. They may go underwater and even fly.
There could be huge blue glass buildings. We'll find ways to make a new start in a memorable world.
Automation will be everywhere. I bet we won't even have to pump our own gas.
Imagine a future where there are more environmentally friendly vehicles and buildings, more plants and grass everywhere.
But we never know. There might be global warming, and our buildings could be crumbling.
The future is hard to predict, but I think we will have giant cities in space, maybe on the moon.
What will happen to the universe in the future? Will we make it?
How will the universe end? For that, we need to look trillions of years into the future. One theory is the Big Crunch. This is when the universe stops expanding. Gravity takes over and causes everything to collapse to one single point. But maybe it rebounds into a new universe. The Big Bounce. The Big Freeze is when everything keeps expanding. Eventually, all of the stars die and only cold gas remains. The Big Rip is when everything is torn apart by the expansion of the universe. Recently, we learned that space is actually accelerating because of dark energy.
What if I told you that the idea of one universe is a lie? That there might actually be more than one universe?
Many scientists have accepted the theory of a multi-universe. Maybe there are billions of bubble universes surrounding our universe. Think about it. No one knows what happens to the stuff when it goes down a black hole. For all we know, it could lead to another place in our universe through a wormhole. Or it could lead to a reverse black hole, a white hole. This might start a new universe. This wormhole tunnel is called an Einstein-Rosen bridge.
Thanks for joining us
on our universal
time travels.
I can't get enough of space, Jose. I want to see more.
Well, you can't see black holes, but we're gonna show them to you anyway. This show needs some cool black holes.
I concur.
Where do black holes come from?
Don't worry. The sun is way too small to turn into a black hole. Only massive stars become black holes. If the star is about 20 times heavier than the sun, the hot core fuses hydrogen quickly, then helium, carbon, oxygen, neon, and silicon, until finally an incredibly dense iron core. Fusion stops, and then...
What is a supernova?
The star collapses upon itself and explodes. This is a supernova. This stellar blast can release more energy than the star produces over its entire lifetime. But inside this expanding nebula, there is still the star's dense iron core, which keeps getting compressed until it becomes a black hole.
What is a black hole?
Our Earth bends 3D space-time, pulling everything towards its center. We call this gravity. The massive sun bends space even more. A black hole bends space so much that nothing can escape its crushing pull, even light if it gets too close. We can show gravity in 2D. The Earth bends space a little, the sun even more, and a black hole bends space to the breaking point.
What is spaghettification?
Like two people pulling silly putty apart, spaghettification is the stretching of an object, like this spaceship. Due to the black hole's enormous gravity, it pulls the closest end much more than the far end. The spaceship stretches and is torn apart into billions of tiny particles.
What happens inside of a black hole?
Like coins getting faster near the center of a gravity well. Gas and dust swirl at blinding speeds as they near a black hole. Once anything crosses the event horizon, that's the point of no return. The black hole's gravity is simply too strong for it to escape. The singularity is at the center. It is infinitely small and infinitely dense. Astronomers are in the dark to explain it any further.
How do you find a black hole if it is black?
How would you find someone in a room if it is dark? We could use infrared detectors to look for heat. For black holes, we use X-ray telescopes. As gas and dust move faster and faster, it spirals toward the black hole and it gets hotter and hotter, producing X-rays. Back on Earth, we can detect this energy with X-ray telescopes.
What are wormholes?
Wormholes are hypothetical superhighways that connect to two black hole tunnels. They could be possible shortcuts for traveling through the galaxy.
We sure did create some amazing stuff.
Well, we had some help.
An astronomical amount of help. But we wouldn't even be here if the universe wasn't so astronomically chill.
Yeah, and we didn't even get to explore all those exoplanets.
And things like dark matter and dark energy.
A lot of mysteries out there to explore.
Maybe we should create another show.
Sure, but after high school.
Hey, I got our next show. Lights, camera, create. College kids take on the universe.
Or create. College kids take on the university. Get it? Because universe is in the word. You guys don't like my joke?
I don't like it at all.
It's not like it's the end of the world.
It's not the end of the world, but it sure is the end of this show.
Alright, well you heard it here. That's the end, guys. Thanks for watching.